In 2006, we held a vote, and we deleted a planet. Not from space, from our textbooks, from our classroom walls, from the solar system models sold in every toy store in America. 76 years of calling it the 9th planet. Erased in a single afternoon. We decided it was too small, too far, not worth the title. And then we sent a spacecraft to look at it. It took 9.5 years to arrive, traveling at 49,600 kilometers per hour. For 9.5 years. What it found when it got there rewrote everything. For decades, the scientific consensus was simple. Pluto was debris, a leftover chunk from the solar system's formation. Too small to matter, too far to visit, too cold to surprise anyone. Every model said the same thing. Pluto orbits the Sun at 5.9 billion kilometers, 39 times farther than Earth. At that distance, sunlight arrives 900 times dimmer than a cloudy afternoon here. Noon on Pluto looks like deep twilight. The surface temperature sits at minus 230 degrees Celsius, cold enough to freeze nitrogen solid, not liquid, solid. At those temperatures, the atmosphere itself crystallizes and falls to the ground. The air becomes rock. A body this small, 2,377 kilometers across, smaller than our own moon, should have lost its internal heat billions of years ago. No heat means no geological activity. No geological activity means no change. No change for billions of years means one thing: dead. That was the scientific verdict going into 2015. Pluto was a relic, sitting in the dark, unchanged since before life existed on Earth. New Horizons arrived July 14th, 2015. Most scientists expected confirmation, not discovery. A quiet, frozen rock. Simple. Unremarkable. One less mystery to explain. It passed within 12,500 kilometers of the surface. It could not slow down, could not orbit, could not return. One pass, one chance. Everything or nothing. Over the next 15 months, it transmitted everything back to Earth. Piece by piece, the verdict collapsed. The image that stopped scientists cold showed something nobody had predicted. Stretched across Pluto's equator, a pale shape, enormous, perfectly formed, glowing white against dark terrain. 1,200 kilometers across. Place it on a map of North America. It swallows Texas and Oklahoma combined. The shape of a heart. The media called it beautiful. Scientists called it wrong, because that heart is a glacier, not water ice. Nitrogen ice. A basin filled with frozen nitrogen that was somehow impossibly still moving. High-resolution images showed the surface divided into irregular polygonal cells, each one 10 to 40 kilometers wide, separated by shallow troughs. The pattern had a name: convection. Warmer material rising from below, spreading outward, cooling, sinking back down along the edges. The entire basin was turning itself over. One complete cycle every 500,000 years. On a world that should have been frozen solid 4 billion years ago. The ice was churning. The question followed immediately. Where was the heat coming from? Pluto has no tidal forces from a nearby giant planet, no significant external energy source. The sun from Pluto's surface is barely brighter than a star. The only possibility was internal. Residual heat from radioactive decay in the rocky core. But a body this size should have exhausted that heat billions of years ago. Every calculation said so. Every calculation was wrong. The geology did not stop at the glacier. New Horizons found mountain ranges made of water ice, rising 3,500 meters above the surrounding terrain. On Pluto, Water ice behaves exactly the way granite behaves on Earth. At minus 220 degrees Celsius, it is just as hard, just as dense, just as permanent. These mountains had sharp edges, clean faces, the kind of features that form recently and haven't had time to erode. Something was still building terrain on a world that should have gone geologically quiet 4 billion years ago. And then came the discovery nobody had theorized. The snow on Pluto is not white, it is dark red. Not from iron, not from volcanic ash, from chemistry. Ultraviolet light from the distant sun breaks apart methane molecules in the upper atmosphere. The fragments reassemble into complex organic compounds called tholins. They drift down from the sky, slowly, continuously, silently, coating every surface in a layer of reddish-brown organic material. The same category of molecules found in every living organism on Earth. Raining down on a world we voted out of the solar system. Every photograph of Pluto's red surface is a photograph of organic chemistry in progress, not geology. Chemistry, falling, silently, on a world we called dead. Wright Mons sits in Pluto's southern hemisphere, 150 kilometers across, 4 kilometers tall, with a central depression at its summit. The shape was unmistakable, a caldera. The New Horizons team was careful in their language. They called it a possible cryovolcano, a structure that erupts not with molten rock, but with a slurry of water ice, nitrogen, ammonia, and methane. The caution made sense. Claiming active volcanism on a world this cold required extraordinary evidence. The evidence arrived anyway. The terrain surrounding Wright Mons had almost no impact. Craters, fresh surface, recently resurfaced. A nearby structure, Picard Mons, showed identical characteristics at an even larger scale. The conclusion was uncomfortable. Pluto had not just experienced geological activity in the distant past. It may have erupted within the last few 100 million years. Some researchers think more recently than that. Stand near Wright Mons, and you would see no lava, feel no heat. You would be standing in near total darkness on terrain that crunches underfoot, looking at a mountain that once forced ice upward through kilometers of frozen crust and expelled it into a sky so cold the material solidified before it could travel far. A volcano, made of ice, on a world that by every calculation should not have had the energy to produce one. Found on a rock most people had stopped thinking about. The glacier presented a structural problem. Its mass, concentrated in one region, should have destabilized Pluto's rotation. The weight was wrong. The physics said Pluto should have tipped. It hadn't. The only explanation that resolved the math was mass underneath. Something heavy, something dense, acting as a counterweight directly beneath the glacier. A 2019 study proposed the answer. Liquid water, not ice. Liquid, kept from freezing by the weight of miles of ice pressing down from above and faint residual heat rising from the core below. An ocean, possibly stable since Pluto's formation. 4.5 billion years, in permanent darkness, sealed beneath kilometers of ice, never touched by sunlight, never disturbed by weather, never reached by anything from outside. The same basic conditions that support life at hydrothermal vents on Earth's ocean floor exist there. Liquid water, mineral-rich rock, a faint energy gradient. Nobody is claiming life exists in that ocean. The evidence does not support that claim. But a decade ago, the idea that Pluto might have habitable conditions was not taken seriously by mainstream science. Today, it is a published research area on a world we demoted because we thought we understood it. Pluto does not do any of this alone. Charon orbits at 19,600 kilometers away, 1,200 212 kilometers wide, more than half of Pluto's own diameter. They do not orbit each other the way the Moon orbits Earth. They orbit a point in space that sits between them, outside of Pluto's surface entirely. Two worlds locked face to face, rotating around empty space. Some scientists refuse to call Charon a moon. They call it a binary partner. Charon's North Pole is stained dark red, not from its own geology, from Pluto's atmosphere. Methane gas escaping from Pluto drifts across 19,600 kilometers of empty space, reaches Charon's cold pole, freezes there. Ultraviolet light processes it into the same Tholins coating Pluto's surface. Pluto is painting its own moon, with its own atmosphere. Two worlds, locked face to face, sharing chemistry, sharing color, in the dark. We spent 76 years classifying it, 9 years arguing about the classification, 0 years understanding what it actually was. The argument was always a distraction. Pluto does not care what we call it. It never did. It is out there right now, 5.9 billion kilometers away. The nitrogen still churning, the organic chemistry still falling, the ocean still waiting in the dark. None of it required our attention. None of it stopped when we looked away. The most expensive mistake in science is not a failed experiment. It is a question we decided was not worth asking. We decided Pluto was not worth asking about. And it turned out to be one of the strangest places we have ever seen, which makes you wonder what else we stopped looking at.